that general formula from the formula sheet to write these expressions here. Yes, we're all happy with that. So now what we have to do is actually expand them properly. We're looking at row 5 of Pascal's triangle. Did we write that already? Yeah. So that was 1, 5, 10, 10, 5, 1. Okay. So we've established that that's Pascal's triangle row 5. And so they are going to represent these numbers here, the 5, 0, the 5, 1, and the 5, 2. Then we need to expand these things. So this is going to become, the 5, 0 is obviously 1. 2k all to the power 5. What's that going to be?
62.
Too many. 32. K5. We did write it up at the top actually. And so what I said the other day, Alex, was that because we've got not just a letter in as our term, we have to make sure that we put it in a bracket and remember that that whole thing is raised. Now, we say this now, and I see, generally I see lots of nods and smiles and say, yes, yes, we're going to do that. And then half of you will forget that when it comes to a test or an assignment. So please, please, please try to make sure that you're following this and using brackets where I've asked you to. The second term, also this, in this case, we've got to be careful, it's actually -3. Okay, so obviously anything to power 0, it's just 1, so we're just going to do that. Now, I'm going a little bit OTT with what I'm writing here. It could be the fact that you're going to start skipping steps, that's fine. But I'm going to go with the whole hog here just so that you are trying to follow that process each time. Right, 5, 1, we know is the number 5. 2k all to the power 4, what would that be? Pardon? 16. K4, yep, and then -3 to the power 1 is obviously just -3. Now also here, I'm keeping it in a bracket because I'm reminding myself that I'm not taking away 3. That's another thing sometimes people get confused with when it comes to these, is they start forgetting that you're multiplying these things together, okay? And then plus, oh no, yes, 5, 2 would be the number 10. And then 2k all cubed would be 8. Oh. Oh, it's very clearly 8k cubed. And what's -3 squared? 9. 9. That's very obvious. Alright, now I'm going to finally do my final answer. So we've got 1, multiply this, so that's obviously just 32k to the power 5. Now, we've got some big multiplications going on here. We've got 5 multiplied by 16 multiplied by -3. We may need a count here. No. Luckily, my license is really charged. -240. So that's -240k to the power 4. And then we're doing 10 multiplied by 8 multiplied by 9. We should be able to do that.
So that's 17?
Yeah, no. And that's going to be plus 720k to the power of 3. And they only asked us for the first 3 terms, so that's why we stopped there. Obviously, we could keep going. Yeah? Oh. All right, next one. We're expanding the first 4 terms. So, as I said before, identify what your A and B are. So, if it helps, actually write next to it, A equals 1 and B is equal to 2x. I'll let you expand that and see if you can do that on your own. Whilst I write back here.
What are we doing?
You're doing that expansion.
Oh.
Right, okay, so we get this answer here once we've done all our expanding. Now, we've been able to follow patterns when we are finding several terms, realistically, a lot of the time, they're going to just want one specific term, okay? And to do that, we're still going to focus on this general formula, okay? So this is going to be our key. We're also going to be focusing on what's A, what's B. Essentially, what we need to do now is always identify the value of R, because we're going to know the value of N. How do we know the value of N? It's always the power of the binomial expansion. So, when we're doing this, alright, so, let's look at an example. So you may be able to find a term given its power. So, find a term containing A cubed in the expansion 2A minus 3B to the power 9. So they only want something that's got an A cubed. Okay? So what we do is we use our general formula. I know what I'm going to do. I'm going to copy this that way. Keep pasting it. Okay? So we're going to use this general formula. And we're going to establish these things. Maybe it helps to start saying, right, what's our value of N in our question? 9. And what's our A? 2A, yeah. And what's our B? And B is minus or negative 3B. Okay? We need to establish what value of R is. So we're going to put those values into our general expansion. We're going to say 9R 2A to the power of 9 minus R negative 3B to the power R. Right, now it's at this stage, what we need to do is to have a look at this and say, right, we want to find the term that has A cubed. Now, will anything to do with this have an A cubed in it? No, okay. Will anything to do with this have an A cubed in it? Yes. Yes, okay. So what we're going to do is we're going to focus, will this have an A cubed? No, that's the number. So we're going to focus just on this first part here. So, if I were to expand this, what would it become? Think about our 2k all to the power 5 we had a minute ago. How did we work that? What happened to it? Yes. Correct. Yes, you're happy with that?
Yeah.
So when you've got two different things in here, it would become that. Now, which of these two things do we need to focus on in order to establish the value of R to get A cubed? This bit here, yes? So this is kind of irrelevant, but it's important. It's going to be important when it comes to doing our expansion, but it's this that we need to focus on. Now, so this question here is a nice one, what she says, and you're probably thinking it's so not nice. But this is a nice one because it's more straightforward, because all we need to do is say, well, look, this bit here has to equal 3, yes? So if 9 minus R has to equal 3, then R has to be 6. Awesome. So then we can go back to our thing up here and fill that in. So we're now going to be working out 9, 6 to A to the power, can we just do that in our heads? 9 take away 6. I did that, like there's 9 take away R, I did that in my head and wrote 3. Was that a bit of a leap?
No. What about you? Well,
Tamir, it's nice that you made it this lesson. Oh, no, you didn't. Enjoy it.
yeah, figure it out now.
Alright, so yeah, so then obviously all of these things are being multiplied together. So you're going to work out 84 multiplied by 8 multiplied by 729. Now, I can't imagine that this kind of question would be on the non-calc paper. Okay? If it was on a non-calc paper, they would probably be slightly nicer numbers and ones that you could do pen and paper if you needed to. Okay? And what is this answer?
4.8988.
And then, so that's A cubed B 6. Now, what I want you to do is just to double check what the actual question was. It says, find the term containing A cubed. So we have done that. Okay? Sometimes they'll say what's the coefficient of the term containing A cubed, and in which case you would just leave it as the 489888. Okay? Just it's a minor point, just to double check it. So, and that's what this next one does. It says find the coefficient of x to the 8. Right, so we use our general expansion. Come on. So there's our general expansion that we've got from our formula booklet. We've got that n is 12, a is represented by 1, and b is represented by negative 2x. Lovely. So then we're going to stick that in. So we've got 12r, oops, 1 to the power of 12 minus r, and then negative 2x to the power of r. So we just follow the same process each time. Identify your n, a, and b, stick it in that general formula. Then you go back to the question. Say, right, okay, what we're trying to look for? We're trying to look for the coefficient of x to the power 8. So does this first thing have anything to do with x to the power? No. Does this have anything to do with the power of x? Does this have anything to do with the power of x?
Yeah.
Yes. So if we were to expand this, again, the number's not so important. Our x would be to the power r. So what value of r are we going to need for this question? 8, yes? We can see that one straight away. We don't even have to do any rearranging. And because this is the only term that has the x with a power, we can say straight away that this would be expanded and go here. So this bit here would be negative 2 to the power r and x to the power r. So this is the only thing we're interested in, so that means that r has to be 8 for this question. So then we put that back in to our general, so we're finding 12, 8, 1 to the power 4, negative 2x to the power 8. And we use our calcs to find 12, 8. I think it's a big number.
2, 6, 7, 2, 0, x.
Okay, so our question was find the coefficient. So really we should then write 1, 2, 6, 7, 2, 0. Okay. Oh, pretty straightforward. Oh. Okay, so unfortunately, most of the questions that we get are more inclined to ones like this, which are a little bit more challenging. The reason being is because they're talking about the coefficient of b to the power 6, but what we can see here is that we've got b's in both a and b. Okay, and so that's going to make it a little bit more challenging. What you need to do first of all is to recognize that this is 1 over b. Whenever we're working with powers, we don't like fractions. So we need to change that to be written as a power rather than as a fraction. How would we do that?
Keep changing.
Not quite. You're dividing fractions. So this part here will actually be known as b to the negative 1. Yes, you're happy with that? Yeah. So what I'm going to do first of all is I'm going to rewrite this. Alright, so all we've done is rather than write 1 over b, we've written b to the power negative 1. Okay? And again, we need to identify n, a, and b. N is 12, a is 2b squared, and b is negative b to the negative 1. Right? We use our general formula. Okay, so we're using our nr a to the n minus r, so that's 12r 2b squared to the power of 12 minus r, negative b to the negative 1 to the power of r. Okay, so let's just read like that first. Alright, so we established that this first number doesn't affect our power. This number here is not going to affect our power either, and the negative value isn't either. Okay, all we're really interested in is the powers of b. Okay, so if I were to expand this part here using this power, what would I have? B to the power of what?
24.
Yes, 24 minus 2r also. Yes, you're happy with that? Because when you have the power of a power, we multiply those terms. Yes? So that's, instead of b squared inside and 12 minus r, we've got 24 minus 2r as our power. This term also has a b with a power in it, so we need to deal with that as well. So if you've got a negative 1 inside the bracket and an r outside, what does that become? Minus r. Awesome. So all we're doing is focusing on the terms that have a b in it. Now we've got two terms with base b that are multiplying together. What do we do there with our powers? Add them, yes? So to simplify this, we would then have b to the power of 24, and then you've got negative 2r, take away r. What's that?
Minus 3.
Yeah.
Wait, Miss Harrison?
Yep.
Didn't you say that we multiply, then we add them?
Yes, so I said negative 2r plus negative r.
Yeah, but is it not 2b? And it's b multiplied?
No, remember the b's, the base, so if you had x to the 4 multiplied by x to the 5, that's just x to the 9. Remember the base doesn't change, yes? But I'm glad you said that because that's what lots of people want to do. Okay, so just don't forget that bit. Alright, so whilst you can't read it very well, we all understand that this is 24 minus 3r, yes? Alright, so it's at this point, remember how before we were like, okay, just comparing what we need? We're looking at b to the power of 6. So what are we going to write now? In order to find r, what
That has 3r has to
yeah, 24 minus 3r has to equal 6 in our question. Now I like my thing I'm trying to solve to be positive, so I'm going to say 24 take away 6 equals 3r. So 18 is equal to 3r, so r is 6. Now, it could well be that when you're doing this question, you just look at this as b to the 6 and you say, oh, then r is 6. And in this particular instance, you'd be fine, okay? So if in doubt, give it a bash, do something, try and do some kind of expansion and see if it works, see if you get a power of 6 that you're looking for. But realistically, you need to make sure you're understanding all of these steps in order to actually find the correct one. Okay, so it could be a guess and check. Chuck a value in and hopefully you do get the correct power, but officially you should be doing this. So we now know that r is 6, which means again we go back to our original general formula here, this one. So we're going to say 12, 6. Oh, that's so not 12, it's 2. 2b squared. 2b squared to the power of 6 negative b to the negative 1 to the power of 6. So, having expanded that, and at secretly you don't really need to deal with the b's because we've actually established that when r is 6, that this is going to simplify to give b to the 6. Okay? So really you don't need to focus on that, you're just looking at the coefficients. being raised to those powers. Okay? But in some cases, it's also a good double check for you. So when we do this, we've got b12 and we've got b negative 6. We know we're multiplying them together, so we add our powers. 12 take away 6, or 12 plus negative 6 is 6. So we've got the right term. So it is a double check for you, but if it's complicated, then don't stress too much about the letters because we've already dealt with them. Does that make sense? And then, so our final step here is obviously to do 924 multiplied by 64.
That's 591.
And I think they just want the coefficient, don't they?
Yeah.
Yeah. You'll notice all of these are the same method, okay? The only difference with each of them is which expression you're going to end up with here and which value you're going to equate it to, okay? So here, the question says, find the constant term. Now, constant terms sometimes freak people out because they're like, well, I don't know what you're talking about. Constant term, what's that? Well, a constant term is where there is no value of x attached to it. In other words, the power of x is 0. Okay? So if you see the phrase constant term, you're going to be finding when the power of x is 0. But the process that we're doing everything else is exactly the same. Okay? So, what did we have to do with this first of all before we start? Get rid of the fraction. Yeah? So how is this going to now be written? We've got say again? No, be careful. Which bit do we need to move? Just the x, yes? What secret power does this have at the moment? Well, it has a 1, and then when we move it, it's going to become -1. This 3 is still there. Okay? So this is going to say negative 3x and a negative 1. You happy with that? So that's your skill of rewriting fractions as powers. So we've rewritten our question, identify n, a, and b. Do you like writing it out, or is that just annoying? So our value of n is 9, a is 2x squared, and b is, I don't know why I put these in brackets. Oh my goodness. Negative 3x and a negative 1. Use the general formula. So we've got not. Alright, so we've written our general formula. Again, we don't need to worry about the coefficients that are being raised to the power, it's just the letters that we're interested in. But x is involved in both of them. So if I were to expand this bit here, I would have x to the power what? 18 minus 2r, and this one would be x to the power of negative r. Then we are adding these two terms. So this gives x to the power of 18 minus 3r. Yes? What do we write then? Knowing that we're finding the constant term. Okay. Good. So in this question, 18 minus 3r has to be 0. Rearrange. Oh my god.
So R6.
Yeah. No, it's not always going to be 6. It's just so in every question we've done R6. And then you put that back in, yes. So whilst it's a little bit laborious, it's actually not too traumatic, is it? Oh, is that a good word? Check me out. Like boring, tedious, time taking. Again, you don't need to worry about the letters, but if you want to, that will just give you your double check. So what's 9 6? 84? Oh my God. And then we've got 2 to the power 3, so that's going to be 8. X to the 6. And then here we do need to deal with the number because it's not just a negative 1. So we've got negative 3 to the power 6. Because it's negative and it's an even power, we know it's a positive number. So what's 3 to the power 6? 729. And that's x to the negative 6. And obviously our x to the 6 and our x to the negative 6 cancel. So that gives us our constant term. So then we're going to work out 84 multiplied by 8 multiplied by 729. 489. Did we just have that? No, did we? 489, 888, 888. 489, 888. 8. I think we did that.